algebraic expressions once again, but here they are not going to be just monomials. There are going to be sums and differences mixed in. So we will continue to simplify, but before we can do any simplifying, we have to make sure that the numerator and the denominator are expressed in factored form. So if you look at this problem, the 5x squared is a term. The 15x is a term. They are connected with a plus or minus sign. We can't do any canceling until we factor. So the numerator must be factored. The denominator, however, 10 is a factor, x squared is a factor. They are connected with multiplication. So in the numerator, the first thing you will put when you're factoring is, if I remember, GCF. And there is a GCF here of 5, they both have a 5, and then x to the first. Factor out the 5x, that would be x here and a 3 here. And you still have a denominator of 10x squared. So now that it is factored, 5 is a factor, x is a factor, x minus 3 as a whole is a factor. You can go ahead and cancel. So the 5 and the 10 will cancel, the x and the x squared will cancel. And there's nothing else to do. We now have in the top x minus 3 and the bottom 2x. And again, you can't cancel the x in the numerator with the x in the denominator because the one in the numerator is a term. And you can't do that minus 3. Next, your numerator does not have a GCF, but it is a square. So you want to factor that. Remember when you factor that, different squares, one will be a plus, one will be a minus, x in the first division, y in the second division. The denominator is already factored for you. What does y minus x squared mean? Right. And just write it out twice so that you can do your canceling. You're not going to be multiplying them back together because the first thing you do is factor. So it's already in factor form. Now you'll notice that there are no two binomials that are exactly the same, but these two are very similar. They're called opposites. That's like having 5 over negative 5. You can cancel them, but when you cancel them, you have to put a negative 1 down. So if you cancel these, it's a negative 1. The reason for that, if you were to factor the negative, say, out of here, it would make the y positive and the x negative, so that it looks exactly the same. That's why you need the negative 1. If you have a sum that's written backwards, it doesn't matter, because 2 plus 3 is the same as 3 plus 2. The order when you add doesn't matter. But if the order is different when you're subtracting, you have to put that negative 1 down. Now, this negative 1, when you simplify it, put it with any of the binomials that have a minus sign in it. The reason I'm saying that is if you distribute that negative 1 into the denominator, it makes the x positive and the y negative. And it just makes it one way. If both numerator and denominator were addition, I would leave the negative outside. But because the one in the denominator was subtraction, I just distribute it. And that's your final answer. You can't cancel the x's because they are terms. You can't cancel the y. Next one. Doesn't look like this is a rational expression, does it? You don't see a numerator and a denominator. What is the denominator here? Closely as well. You guys see the negative 2 on the x minus 4? Okay. Yeah, look, there's actually 2 of them on the bottom. So yeah, this actually is down here. Because of the negative x. sign post minus. X is in the first position. 2 factors of 4 become as 5, which is 4 and 1. Here, this x minus 4 squared, just write it out twice. That way you can cancel the one on the top and the bottom, and you have x minus 1 over x minus 4. So once you have the factors completed, cancel anything that is exactly the same, cancel any opposites and put a negative 1 down, and then make sure you simplify the bottom. Next. Next thing we are doing, and we talked about this before, was domain and zero. Two things that we discussed with domains before. You cannot take the square root of a negative number. This one doesn't have any square root in it. And you can't divide by 0. Since you cannot divide by 0, you need to make sure that your denominator will not equal 0. So what you want to do is figure out the value of a variable in the denominator, which would make the denominator 0. So to do that, you want to factor the denominator. For your zeros, those are the values that will make the entire function equal 0. Remember, this is just functional notation. It's like having a line in your equation. You do that back in chapter 3. So to figure out your zeros, you need to figure out when the numerator will be 0, because what is 0 divided by anything? Right? It is 0. So you want to figure out what will make any of the factors in the numerator 0. So to figure that out, you have to factor the numerator. So for these problems, you want to start the same way you did the previous one. Factor completely. Your numerator here is a difference of squares. That means 1 plus 1 minus x is in the first position, and it would be 3 plus 3 for your 9. Remember, inner and outer should cancel. That's why you need to take number in both for opposite signs. Your denominator has a GCF of x. When you take the x out, you get x minus 9. So remember, domain goes to denominator. Your domain, if there are no variables in the denominator, it's all real numbers. Your values that would make the denominator 0, what would make this back to 0? How about this one? Not negative 9, so positive 9. So our domain is x such that x does not equal 0 or 9. And just remember, if there are no variables in the denominator, it is all real numbers. Your 0 comes as the numerator. What value of x would make this factor 0? That I would make it 6. Negative 3. And on this one, positive 3. So your zeros are at negative 3 and 3. So you start the problem the same way. Your zeros come from the numerator, your domain comes from the denominator. If you happen to get something that will cancel, don't cancel it. If you cancel, you change the function. So it's not the original problem anymore. Okay, so on these ones, you don't want to do it. It's on this one, we can do it. Do the same thing here. We want to factor the numerator and denominator completely. Your numerator does not have GCF. So if we do trial and error, we know that 1 is plus, 1 is minus. Let's try to figure it out without the tic-tac-toe chart. 2x and x. I think yes, 3 and 3, see if they work. If you do outer, you get negative 6x. Inner, positive 3x. That gives you negative 3x. We want it to be positive 3x. So we're going to switch where our minus sign is. So this gives you positive 6x minus 3x. Your domain is x such that x does not equal what three values can't x be. Three values can't x be. We're looking at the denominator. And I only listed them in order from least to greatest because that's the way the homework is the answer that they did. I don't care what order you have as long as you have all three. Your zeros come from the numerator. There are two zeros. What are the two zeros? Okay, don't forget, if 2x minus 3 equals 0, it's going to be a fraction now. You add 3 and divide by 2. So it's actually 2 half and negative 3. Remember, this is one variable and you can have a fraction. Any questions? You are doing 230 even. Remember, right off the bat for number 2, you have to factor the numerator before you can do any canceling. So take out the UCF in number 2. Then you can do your canceling. And then put everything that you have left together. If you end up with x and an x plus 5, leave it that way. X times x plus 5, don't distribute. The only time I would say to distribute is if you have a negative 1. Well, you can't do the 30. Well, that's because I only had an x squared and an x. You don't have to do the 3 and the 6 separately. You don't have to do the whole. Do the 3 this is a large